So question 4 from the Year 12 exam is a triangles question where you have to work out some angles and some lengths. So it gives us some information in the question. It says that AB is 12 meters, BC and BD are both 7 meters, and angle BAC, that one there, is 27 degrees. And part A wants us to find to one decimal place the size of angle ACB. So it's that angle up there. So I'm going to just redraw this triangle underneath. Just sketch that out. That's the one I'm trying to find, and that's 27. And because the question involves two sides and two opposite angles, so x and 12 and 7 and 27, I'm going to use the sine rule. Now I'm trying to find an angle, so it's more useful to have it this way up. So I've written A and B in mine, so I'm just going to relabel my triangle. I'm going to say that that one is capital A, that one is lowercase a, that one is capital B, and that one is lowercase b. You can use their labelling if you'd rather and just rewrite the rule. So sine of capital A is sine of x, and that's over lowercase a, which is 12. And that's equal to sine of capital B, which is sine of 27, over lowercase b, which is 7. So I need to rearrange this to make this the subject. So I'm going to multiply by 12. So sine x equals sine 27 over 7 times 12. And I'll just pop that in my calculator. So that gives me that sine of x is equal to 0.778. And then to find x, I just need to inverse sine. Comes out as 51.10. So I'm just going to check that seems right. So if I look at my diagram, this is much longer. This is a small angle. So actually this would be an obtuse angle. So I'm just going to need to work out the corresponding obtuse angle. So if I draw my sine graph, 51.1 would be there, and there's a corresponding one there that's 180 minus 51.1. So x is 180 minus 51.1, which is 128.9 degrees. So that's part A done. Now part B, it says steel beams can only be bought in whole metre lengths. Find the minimum length of steel that needs to be bought to make the complete structure. So we have this length here, we have this length here and this length here. The length that we don't have is AD up here. So I'm going to draw this big triangle out and then work out the length of AD. So the big triangle that one's 27. And if I do some working out, I can work out what this angle and all of these missing angles are actually. So if I go back over to my original picture, that one ended up being 128.9, which means that one is 51.1. Because that one and that one are the same length, I know that that one is 51.1. And then because I know that each triangle, the angles sum to 180, that one must be 24.1. That one must be 77.8. So altogether, they would be 101.9. So I'm going to use that in my working. So that one there is 101.9. It's 51.1. I won't necessarily need them all. This side is 12. This side is 7. And that's the one that I'm trying to find. So I think it makes sense to use the cosine rule here. So if that's the one I'm trying to find, I'm just going to call it lowercase a, capital A, and B and C can go either way around. So the cosine rule, a squared equals b squared plus c squared minus 2bc cos a. So if I substitute in my values, x squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times cos of 101.9. So I'm just going to put all of that in my calculator. So if I put all of this in my calculator, I get that x squared is 227.7. It's a long decimal. So if I square root that to find x, the square root of that is 15.09 meters. So I'll put that on my diagram. And then to find, mustn't forget to finish the question, so we need to find the total length. So the total length is 15.09 plus 7 plus 7 plus 12, which comes out as 41.09 meters. So they must buy 42 meters of steel. Okay, so that's question 4 done.